Yeah, so today maybe we review just the basic things we started with and defer this data visualization for later. Maybe we can start by just going over any questions you have, or maybe looking at the assignments. We can just go over all the questions one by one from the lab. Does that sound like a plan?
Yeah, that's a good plan. Yeah.
Yeah. So shall I start from lab one and we just go forwards, or how do we do this? Yeah.
Yes. Yeah.
Okay. So maybe one way to do this would be if I just first open up. So the important thing I want to tell all of you is definitely practice this idea of when you look at writing code, definitely practice this idea of spending enough time on the question itself, right? Trying to understand the question is something, even today, I improved the way. Like yesterday, somebody was trying to ask me a math problem, and they were amused that I asked them the question to repeat the question like 5 times, right? And then I said, no, the thing is that very often there's information in the question, and we must make sure that we internalize that information pretty well, right? Okay, so question one. Uh, so what do you see from this question? I think Prakash is here. Hi, Prakash. Okay, we'll say hello in a minute. Um, so what do you see from question one? Give me some ideas. How do we want to solve it? Yeah. Anyone? Who wants to give some discussion of question one? How do you want to solve it? Oh, can you see my screen? Is it on the screen?
Yes, Vijay, we all can see your screen.
Okay. So how do you approach it? What is the idea here?
So Vijay, it was like it was just trying to count just like the girl, how she's counting.
Mm.
We would start from the same set of fingers,
Mm-hmm.
like thumb, index, middle in the same order.
Yes. So okay, so let me just take you to code board. Maybe we can go here. So okay, so first of all, in code board, I want all of you to understand one operational thing, right? Which is you can always run the solution by running main, but of course I want all of you to focus on running the tests, right? So we want to initially it's very easy to put print statements in main and see what is going on there, but later we want to go to running the tests because that's a probably more robust mechanism. So actually, let me ask that as a question. How do you all feel about creating tests and running tests? Feel like it feels natural, or it's still not yet second nature?
Vijay, it has not come naturally to us. There
Yes.
is a little bit of struggle that is involved,
Okay.
and in the second assignment,
Yeah.
or the second uh, what do we call that? Basically the second chapter.
Yeah.
Okay, I saw that that the test code is not being called anywhere. It is not being. It has not actually been used. So I could not understand
Okay.
how it is being invoked like other functions. So I
Oh,
invoke other functions on the main itself, but
yeah.
I do not see where the test is being invoked.
Okay, that's a good point. So let us look at this right now in this context, right? There's a bunch of tests, and if I run the tests, it will execute this package, right? And there'll be failures because there's no code implemented here, right? So there'll be failures. So now can we ask your question again? So right now you see, do you still have this question? How is the test being invoked? Hi Prakash, now I can see you.
Hi.
Yeah. So Prakash, today, just since you joined a second later, I'm planning to spend time today just reviewing our labs, answering questions, trying to consolidate everything we discussed. Hopefully that is the
Yeah, sure.
so don't hesitate. I'm trying to encourage everybody. Don't feel that anything is too simple to ask. Any question is welcome, and I will try to provide either the direct answer or give some more perspective on it. Okay, so don't hesitate.
Yeah, sure.
So yes, Kiran. So do you still have the question now?
Yes, Vijay, I still have the question. I can see that I can clearly see that it has both the result, the expected result, and the input parameter being passed inside the function. But where is the function being called? I don't understand where the function is being invoked.
No, I understand. So let me start from the beginning. Okay, so the first idea here is whenever we want, right now we're using a testing module called unit test. The reason we're using unit test is packaged in with Python, right? So whenever you install Python, you get unit test along with it. Point number one. So now the point number two is how do we write tests using unit test? So there is a small feature here that we have not spent enough time on. So right now you take it as boilerplate. That is, you have to create a class. And in Python, you create a class using this keyword here. Class, you can give it any name you want. And it has to basically inherit from unit test.test case. Okay. And you don't need to use any more knowledge than this as a fixed structure that we will use every time we want to create tests. Right? You give any name you want. You have to use the class keyword, any name you want, and then you have to basically put unit test.test case in the parentheses. So that's just set up for you. Later, when we discuss object-oriented programming in some detail, we can talk about what that actually does. Okay, but now, then after you do this, everything starts to become very, very straightforward. You write your test function using a def, like any function in Python, but the name of the function has to start with test underscore. Now you might ask, why does the name have to start like this? And the idea is that uh, unit test searches for tests in the code, right? And every time it finds a function of this kind, it knows there's an extra test being added to the system. So the discovery, it's called test discovery. The discovery proceeds by checking the name of the function. Okay. Anyway, again, it's boilerplate, right? So now the important question is, if I want to create a new test, what do I have to do? Well, I can just def it. I can call it test underscore new. And it has to have, this is another part of the object-oriented thing. It has to have basically this parameter self in it. Okay. And then once you're done with this, now the entire core of the test is basically to assert something. So assert, basically, as I said in the first session, a test is done by asserting something is equal to something. So we do that in this unit test framework by saying self.assert equal, right? And then you say whatever, A equals B. So you pass them as parameters, right? That is the quick summary of how to write a test, right? So that's the first starting point. Now the next part is, once you have done this, this is the question that Kiran was asking. Who is going to call this function, right? Who's going to make this class and call this function? And the idea is that when you can do this from the command line by invoking the test library, but right now you don't have to worry about that even, because when you click this button, the command line is already executed for you. When the command line is executed, it goes into the test library and it launches up this file. It doesn't launch main, it launches this file. And then from this file, it proceeds to execute every test that is mentioned here. So that is a picture you should have in mind, right? So when you click this button, when you click run, main is launched. When you click test, main test is launched. And from main test, it will load up all the imports that are needed, blah, 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 and do everything that's. So that was a detour, but does that answer your question now, Kiran?
Yeah, Vijay, it answers the question now.
Okay. Okay. Is there a clarify for it? Did any of you have uh, either that question or related question? Anything related to this? Just this is a good moment to just review. So okay, as well, let's have a quick discussion on this idea, right? Because in the beginning, and very often, even today, I feel this sometimes. This feels a little like a piece of work to do. So when I need to write something quickly, sometimes I go to main, right? Instead of writing this here, I go to main and put a print statement. So we have to spend a minute asking what could be done or said right now to make this feel almost as easy as working in main. All you have to do a new, instead of a print statement in main, you just copy this and you create a new test, right? So have I said enough to convince you that this is where you would go, or you still feel like you want to go to main?
Vijay, I have not been able to understand this piece.
Which piece?
Yeah, I could not follow you on this.
Yeah, I couldn't follow either.
No. Give me some, understand what?
So you said that we may not have to go to main and write a print function to understand or to
No.
check.
Whenever you approach a new problem,
Yes.
why do we put a print statement in main? Because we want to see something happen, right?
Yes, right.
Am I working correctly? Blah, blah, blah. So I'm saying, so for example, let us make an example, a silly example, but an example nonetheless. Let's go to testing.py. I'm saying, and look at this example. I'm writing this function square of a number, right? It's a very simple function. It takes a number and it multiplies it with itself and returns it. Now, usually you would say print and then you would say print 4 or something. So let's do that exercise. So you would go here and you would say something like this, right? Okay, I've written a big print statement, but effectively it invokes this function t.square with the value 3.
Yes.
Okay, now I'm telling you, this is what we all naturally want to do. And then we run it and we get the value 9 and we say, oh, it looks good, right? So if I actually run this, probably it will say 9 somewhere. There'll be some errors because I'm running something. So let me just comment out everything else. So if you run this, it's going to work and you're going to see an output, right? So this is good. So we feel happy. We say, oh, my code is working and everything feels good. This is why we keep doing these print statements. However, now I want to highlight the equivalent of doing this is you go to main test. And just to make our code clean without any errors, let me just comment out every other test. This is a good way to work so that you don't get too many errors and things cause trouble, etc. You can just do this for now, right? So I have a test. Let's call it test SQ square or something. And here, what happens if I put the value 3 into the function, I should get 9 as the square, right? So here I will put t dot square and I will put the value 3 into it, right? So if you do this, it will do equivalently what we did before, right? This will be kind of, so let's run this test and see what happens. Okay, it says ran one test and it says I passed the test. Now, what is the benefit of doing this versus the print in main? The key benefit of doing this versus the print in main is I don't have to use 1 second of energy in my head to check if the answer was correct, yes? Like, for example, let's say this was a complicated function and I'm still working on it. And suppose I do something and I make this, right? If I multiply by 2 when I return it. Now, if I run main, I have to go to main. I have to see the output and say 3 is not equal to 18. I have to use my brain to say that this is broken, right? The Python is not telling you anything is broken here. Just saying whatever you've asked me to run, I've run it. But if you run test now, it's going to actually say I failed my test, yeah? And it does better. It actually says 9 is not equal to 18. So now we have to ask the question, which one is better? If
But
we are,
anyway, in the test also, we need to write that, right? You're saying instead of printing and checking,
yes.
but before we are coding, then we need to come up with all the test cases and
Well, before or after, right? So there is another discussion here that says, okay, if first you have to agree, we're going step by step logically. First, you have to agree that these tests are actually kind of cool way to check my code is working correct, right? It's better than print statements because once I've written the test, I can switch off my brain. I don't have to use my brain to figure out is this code executing correctly? Is it working? Is it not? Right? I don't have to stay alert. I can keep running the test. And imagine you have a big file with thousands of tests in it. If you have a lot of print statements, 100 print statements, you read all of them and see if anything is broken, right? That's a lot of time to check. And it's very hard, right? As I was saying, if you have print statements that look like this, it doesn't highlight your attention anything is broken. It says the square of 3 is 18, which is obviously wrong, but until I use my brain power, I cannot detect any problem here, right? So if we invest, so now first question is, therefore we should probably invest time in testing. Second is, it's fairly easy to write the test. It's not any much harder, right here, it's not any much harder than the print statement, right? Maybe I have to write one def here or something, a little bit extra work is it? It's not that much harder. So are we all convinced that we will start writing these tests? At least I'm trying to remove the obstacles. So now you have to raise obstacles. Tell me why we won't write more tests.
So, Vijay, while I agree that this is very useful in complex scenarios or, a little more advanced scenarios, but in all our scenarios, how I was doing was that I would first print and check whether the result is as per what I wanted, and then I would go in and write something in the tests so that, my results are complete, my solution is complete.
Yes, yes. No, so I understand this response, but I'm trying to rewire our brains. And I'm
Yep.
saying to you that if you start doing this,
Right.
very quickly you will find that it is as natural for you to write a test as a print statement. Because a test is, huh?
I can see that. I can see it's just as good as even in print. In print, while we have to write dot format and all those things here, even that is not required.
Yeah.
Everything,
Yeah, it's doing a little bit more work.
both input and output can be written here, mentioned here.
Correct. So the point only is the main difference is the test forces you to ask the question, tell precisely what I expect, right? The
Yeah.
print is kind of vague. Okay, just show something. I don't care, right? So yes, so the test requires a little extra effort from us, but I'm trying to suggest that once you start doing this, it will become second nature. And in most projects, it's not a question of big projects, I think. Once you start doing this, even in small projects, you will start writing tests, right?
Yeah.
And you will start exploring this way. But anyway, print is something we are born with, so I'm not trying to remove prints. I'm just showing you that this has tremendous value for you, right? I mean, especially when you want to become a kind of semi-professional software developer, probably it makes sense to start putting this into your code as you go along so that eventually when your code becomes bigger and more complex, you change anything, you don't have to worry about verifying that your code hasn't broken it.
Vijay, I want to take you to this problem. If this one, the standard deviation thing where you have mentioned round
Yeah,
it to
yeah.
decimal.
Yeah, just hold that one question, Kiran. Just 1 second. So let me wrap up tests quickly, and then we'll come to the questions, right? One by one, we'll go through the questions.
Okay, sure.
Yeah, just please don't forget to ask me when we get to round. So, so what am I saying now? So now I'm saying the follow-up comment to Prakash about tests is, once you're committed to writing tests, it is an interesting question to ask. Should we write the function first or we should write the test first? Okay, and there is a good case to be made saying write the test first, because the test can actually help you translate the requirement. Right? Whatever this requirement is, it can help you translate this requirement into a very concrete expectation for what is the output.
Yeah.
Right? So for example, to go back to our example of the square function, if we think that we want to write a square function, then before I write the function, I should have some idea that if I put a value 2 into square, I should get 4. If I put a value 3 into square, I should get 9, etc. It's a very concrete expectation. So there is a good reason that you could write the test even before you write the function. Of course, for a small function like square, okay, it doesn't really matter which one you write first. But when you're writing a bigger piece of functionality, maybe it makes sense to write the test even first before you write the code. So let me ask that as a question. How many of you feel that you would actually write the test first, and how many feel you would write the test after?
VJ, I agree to the point that we should write the test first, but won't there be any issues that the functions, the actual functions are not written, not
Okay.
complete yet, but these tests are going on because they would
Okay,
exist every
so
time.
of course, so we should go and look at that question. So for example, let's pretend that this function is not written, right? I just renamed it for now. I can comment it out even better. So if I remove this function, let's see what it says. So if I run the test right now, yeah, it says there's a failure error, right? It says clearly module has no attribute square. So of course, the problem here is that now if I wrote this test, it's making some errors. And let's say we don't want to see any errors on the screen. My goal is to not have errors on the screen. So the first thing you do in that scenario is you come here and you what is called create the function signature or the function stub, right? So you stub out the function, you take this out and you replace this part, the body of the code which you have not yet written, with just this much.
Okay.
Right?
Yeah.
You just say pass. Now you run the test again. At least that error will be gone. We will get what we expect in any test. You get an assertion error. But that
Okay.
is fine because what you're returning from the function is basically blank, and blank is not equal to 9 in this case. Right?
So this is more like a warning which can be ignored
Correct.
for now.
Correct. So, and actually, usually when you're running tests, you only read the top part usually. That's all you need to read, right? Because only when you are debugging your code and trying to find out what is broken actually, then you can go and look inside for details, right? Since we haven't implemented the function right now, I wouldn't even go into details. I would just say, okay, fine. At least the whole thing is not blowing up and crashing. I can do something, and I expect one test to fail. Yes, it fails. Then I would go and next step, I would implement this. And see, the cool thing is now, as soon as you implement this, then it just basically immediately gives me feedback and says everything's good, right? So we can celebrate and go for a coffee. So I think that is the workflow, right? Come in, you write the headers. And another thing I will show you, if you go to the code exercise, in some cases, I have actually given you the function signature. So you can even start by just taking this thing, go to your codeboard file, just as an example, I'll put it here for now. Go to your codeboard file, and you could just start by just defing right away from here, right? So even before anything happens, you got everything you need, right? And you can even put some comments in here, but you're ready to start very quick, right? And then you can start say, okay, now when I convert number to finger, so let's do this right here. What is the test that we should create for this? Recommend me a test. What is the test we want?
So BJ, you want a test for convert number to finger?
Yeah.
Okay. So basically, we could count until 6, for example, and check which finger it should come, and that is the result expected from
Okay,
the.
so we'll go here. We'll say that I'm just saying here you will say def, and then you will say test, right? Whatever the function is, count number to. I mean, this name doesn't matter, right? You're going to call it test 1, 2, 3, 4, but it's nice to have a good name. And here you're going to write the test, right? And it's now we are good at this. Self dot assert equal, and here we are just going to say if I run this function, what did you say, Kiran? When you run it for 6, what are you going to get?
1, 2, 3,
Or
4.
whatever you can see. The nice thing about this, you can run it for any number, right? So you can even start with, okay, I started with a thumb, I guess. See, that's another nice thing. If you go back to the requirements, I've already given you this. See, you see how the workflow is very matched with our requirements, right? Here's the test already. Yes. So you say count number to finger 2, and you have to return index. So I just go here, count number to finger 2, and I just say index, right? And notice all kinds of problems will be taken care of if you do this properly. For example, if I copied it from there, if I copied it from here, it says that it has to be lowercase index, right? So when I write the test already, so somebody makes a mistake that I put uppercase index, still a correct, semantically correct thing, but you will fail my test when I grade your code, right? So if you follow this path, it's less likely to make mistakes. This is now already encoded into my program, right? Okay, the only extra thing you have to ask is, where is number to finger defined? Really, we want to define it in counting.py or something, right? So it's in this file. So all the last piece of work to be done is counting.py is implemented as C. So we have to say C dot blah, 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 right? And then we're good to go. Right, okay, so let's see. This has not been implemented. So now we have 2 tests. We passed one, we failed one, right? And then once we implement this, then we are good to go. So, okay, so we went through this painfully, but now have I changed anyone's minds, or you're already here?
Vijay, this is good. I agree with the test.
Yeah. I'm saying that, of course, I will say that just give it a chance, no? Try a little bit.
Yeah.
It is a behavior change for all of us, and I sympathize with the feeling. I also, once in a way, sometimes I get lazy, and I want to quickly put a print statement somewhere, right? But
So writing test cases is the only option to debug your code, or is there any option like to debug your code in Python, similar to like we have in other language?
so say the question.
So like this writing test cases, test code basically is the only option to debug your code.
No, so I want to use a different word here. It's the only option to test your code. So that means when I say test your code, it means this is the only option to find out if there are problems in my code.
Okay.
Right? So this is, no, I don't say only option, but it's a good option to find out if there are problems in my code. The debug word we will use once we say, now if I have a problem, what do I do next? Right?
Yes.
I have a problem, what do I do next? And the answer to that question is, of course, very difficult question to answer. The small answer to that question right now is, then you go back and you look at the code. Then the second thing you can do is you can put some print statements in your code to see what is happening. That's the easiest way to debug. Right? It's the simplest way to debug. The next level, which we didn't do, but I can do for you sometime, the next level becomes using a debugger. Right? And in a debugger, you can execute your code line by line, etc.
Yes.
Right? So again, it's an interesting question. When do I actually need a debugger? And I'm going to say to you that, because it's available in IDEs, etc., we get used to debuggers and we use them even when we don't need them. But okay, I would not push the case too far, right? I mean, what we are trying in this course is not to master the debugger, but to master how can we write a code without making too many errors, right? But it's almost like you can do a whole separate course on how to debug, right? Because there's so many tricks and twists in there. So the skill we are trying to develop here is how can we understand the requirements and write the code making minimum mistakes, right? And then that will be okay. So with this preamble, so what about the others? Is anyone convinced now that this is a good way to start? Will write more tests or no? You can say no if you're
Yeah,
not
that is
convinced.
No, this
nice,
is good
but
actually. I like that.
as part of the unit.
Yes,
Sorry,
Prakash.
go ahead. So as part of that unit test package you said, right? What all functions, I mean, are available?
Just one more
What
time,
all
can you repeat?
list
Repeat.
of things that are available? So
Ha.
you said that the unit test package is available when we install Python, right?
Yes.
So as part of that particular package, what all functions are available? Like here in this particular piece of code, you have written assert equal, assert true, false,
Yes.
assert is instance. So what
Correct.
are there should be an exhaustive list, right? Like
Exhaustive
just
list. Yes. And I can actually, well, you know what? So now today we should start doing this. So if you just go to unit test Python, right? If you just go, so one of the nice things is Python is heavily documented. Okay. So if you go to unittest.python, you will get the documentation. And I think we're at the right time in this course to say, for me to say, we should all start reading a little bit of the documentation. What I would say for sure is that the Python documentation is very, very, very good, right? It's unexpectedly good, right?
okay.
So please browse around. The only thing I would say to you is you can get lost once you go away from carefully arranged course material for you. There's the world opens up, right? And you can get lost in here. So just go and explore. I want all of you to do this, but don't get overwhelmed and say, oh my goodness, testing is like an ocean. I cannot master this and give up on it, right? I don't want to send you here and have you disillusioned or scared or intimidated, right? So definitely you can explore this. Now I'm going to come back and say, okay, having said all this, I'm going to say assert equal is, you can get a long way with assert equals.
Okay.
Right? You see, for example, let me show you this example. I have this assert. By the way, the font and screen is readable for all of you, right?
Yes,
Yeah.
it is.
So
It's quite readable.
if I use this example, assert true, 2 is equal to 4 by 2. I can easily rewrite this as assert equals 2 comma 2. Actually, it's up on the previous line, right? Or whatever. I can even rewrite it in the exact form, right? This one, instead of writing it this way, I just write it this way. 2 equals 4 by 2, right? So that means I don't really need this assert true, right? And just if you feel like your test looks a little nicer because you said assert true instead of assert equal, but I don't think it's needed. So there's assert true, assert false. Some of these things are like there for kind of convenience, but you can just go a long way with just assert equal. Does that make sense? So maybe I am advocating to all of you, for starters, be minimalistic. Don't include all the new capabilities of unit test. Just start pretending that all we can do right now is check if something is equal to something.
Okay.
Okay, and that will get you a long way. Right? It will get you a long way, and then later we can say, okay, are there some nice convenience functions that can do better for me? Or if you run into a test that you feel you cannot do with an equal, then you just let me know. I will have a quick discussion about it, and then we can solve. Is that a good strategy?
Yes, Vijay. Excellent.
Yeah. What about Prakash? You feel okay with that?
Yeah, that's perfect.
Yeah. So okay, so let's go with this idea. So now I'm still pushing the line, because I want you to push back on me. If something is not feeling comfortable, you have to tell me, right? So then I can tell some other example or something. But are you feeling more comfortable? Did anything that I show you help change your mind, or you haven't changed anything?
It has, Vijay, because now, at least now, I understand a little bit of nuances of these, basically the testing. So I appreciate now.
Yeah.
Earlier I was not able to connect to it because I didn't know where it is being called. How does it give me the grades?
Yes.
So basically, if my test is not passing, my
Yes.
grades will automatically not appear. So they would be
Yes.
like lesser percentage, and that was something which was worrying me a lot.
Yes. Yes.
Now I
So okay.
understand that it's checking
Yes.
internally, and also I can see a connect between the name of the function and the name of the test function that has been mentioned here, which has been
Correct.
handled by you in the backend. Now,
Correct.
I didn't even understand that. I was not understanding where it is being invoked. So all those things are clear to me. To
Good.
me.
Good. Good. What about the others? Did I change anyone else's mind a little bit?
Yes, same for me actually, as Kiran said. Now I can connect actually what is the like use of the test cases.
Good. Good. Also remember, I want to create this thing. Today we are lucky. I came here and I talked about it. I'm happy, right? I'm happy. You're happy. But please, if there are things like this, you must also make it into a question and push me. Okay, Vijay, what you're telling tests and you're grading with tests? I don't know what the hell is going on, right? Just I'm not asking you to insult me, but you can be a little bit, like forceful about it, right? Don't accept it just because I put it there, right? So just say, okay, it's not clear. But Kiran, I want to now say, since you mentioned the word grading, I want to say something about what I have done to make your life easy, right? When you write an assignment, many courses, when you write an assignment and you submit for grading, you have no idea what your grade is going to be, and you have no idea if something is wrong, what is the mistake you made. Do you agree? Think of it, all the tests you have taken in the past. Do you have any idea what grade you're going to get? I mean, you have some
No,
idea.
Vijay, I just think that if I start looking at the code and I also relook at the function that I have written, why I didn't score anything even after writing the function, and I could see the result in the main. So, but what I would finally get in the grades, that is something which is unpredictable. I don't
No,
understand.
wait. I know. But forget about my test right now. I'm going to show you how I gave you a very powerful tool. But now I'm asking about all the tests you've done in your life up until today. When you submit something for grading, do you know for sure what grade you're going to get?
Yes, in some cases, if it is not very subjective kind of thing, I would be able to make out what I'm going to get out of it.
How will you know?
So maybe I would Google and check the answers.
Yeah,
So
but
I'm not
maybe
talking about coding in particular. I'm talking about in general when I would have given exams or when I would have given written papers.
I understand, but it's in general you can get close, but you have no guarantees, right?
Yes, no guarantee. Yes.
Yeah, no guarantees. Now I'm showing you that I've actually done better. I'm giving you guarantees. So how does the guarantees work? I'm saying you should take all the tests that I've written for you and you should really read the test, right? You should read the test, you should understand the test, and you should. So here are all the tests for this module, right? Here are all the tests for this module. So let's take an example. Finding square root. Do you see this test here?
Yeah.
I have actually written the test for you.
Yes.
And I'm saying, Kiran, if you produce a square root function that when it is given the input 4, 1, 1, it's going to return the values 2, 3, right? It's telling you that if you succeed in writing such a function, you pass the test, right? You pass the test if your function does this. And it's, of course, the first parameter is already clear. Square root of 4 is 2,
Yes.
right?
Yes.
So now the question is, what is the second parameter? But the second parameter, if you go back, now I'm saying, if you go back to the testing, you see here, very clearly I have said, this is what I said, if you work like this, you copy this and you start your work with this, right? It says,
Yeah.
clearly, I want the answer, which is the square root, and then I want the step count, right? So now
Yes.
this is saying you need to find the square root, but it needs to find it in 3 steps. Make sense?
Yep.
Yeah.
Yeah.
So now I'm saying if you write a function that passes this test, I'm telling you that when I grade you, I will check the same thing. And so if you pass this test, then you're going to get 100% on that particular question at least. Make sense?
Yep. Yep. Yes, Vijay. It makes
Okay.
sense.
And if you make a mistake, then you're going to get a mistake right here. On this, you're going to get an output error here that says exactly what your mistake is. Right? Then you're going to go to the next step of fixing the mistake. So the first thing, therefore, I'm saying to you, when you do these labs, the first thing is you write the code and then you look at the tests and you run the test. And if things are not working, you try to understand the test and then ask why my code is not matching this, right? And that will prevent all kinds of small mistakes. Like I said, if you here, look at this example. This is the test I'm using to check this convert number to finger, right? The test we just wrote basically. So for example, if you had coded with a capital I or something like this, if you do anything in main and print out something, you may not catch this bug. Then you're going to submit and you're not going to get the grade and you're like, my code is correct, right? And I say, no, your code is not correct. And then I show you why it's not correct because I take you back here and show you the error from here. Does that make sense?
Yes.
Yeah. So for example, you could have done this find square root and forgot to return step count. You could have just written the number 4 or 2 or whatever, right? And then you're not going to get the grade. And you're like, well, I got the square root, but you didn't carefully read the lab instruction, which asks for more than square root, yes?
Yes.
Okay, so now I'm asking you, isn't this a wonderful way to validate your work and guarantee the grades that you get?
It is VJ, because I think it also helps you in quickly checking the answers, because you cannot check individual code for each of us. So
No,
I can
check. No, so let me just tell this as well. It is not laziness that motivated me.
No, VJ, I didn't say that.
No. I want to give the insight though. It's not laziness that motivates. Of course,
it is also the method basically, VJ. It is because I did a shortcut, because I know that I wanted to check. I mean, I just wanted to quickly complete this exercise, so I did a shortcut. I did not go through the iterative method. I tried giving perfect squares only, and then my function was only able to calculate roots of perfect squares, and it would not go the iterative.
Yes,
so I kind of ignored that iteration part.
No. We'll go through your solution specifically. I will show you also. Okay. So we're cutting there. So anyway, so let me just give the insight quickly about why I'm doing this. Yes, it is a good way to grade automatically. So if I have 25 students, I can have it automated. But the more important thing is, if you are working at some time when I am not on the computer and not available to grade your score, you are still able to finish your work and go close the chapter, right?
Yeah.
You can actually write your code, you can test it, you can submit it, you get 80%, you fix something, you get 100%, and you're done.
Yeah.
If I'm going to grade it manually, you do something, if there's a mistake there, you won't know until I put the grade.
Yes.
And you don't get a chance to fix your mistake and get the 100%, right? Or I have to reopen the test, so blah, blah, blah.
Yes.
Then I have to come back and check it, and we'll keep going round and round. Every time you fix a problem, I have to regrade your test.
Yep.
Right? So what I've actually done for you...
That will be a longer process.
No, I know. And it's not fun for you as a student, because you're like, okay, I spent 1 hour on Friday. When I finish, I'm not sure I'm getting 100%. I just know that I've done all the hard work. That's all. I hope to get 100%. Here, I'm showing you a way to be sure that your work is good. And every time you finish writing the code, you hit submit. I don't want you to submit many times. Don't get into that habit. That's a bad habit. That's a bad habit that says, I haven't checked my code thoroughly and I will just hit submit and see what grade I get. It's like guessing the answer, right? But the good habit is to put all the work, make sure you pass all the tests. The test will teach you what you have to write. Then hit submit. And if you still get an error, maybe you can. What I want to give you a guarantee is, if you pass all the tests, when you hit submit, you should get 100%. If you don't get 100% when you submit, then you just send me a mail and say, Vijay, I passed all the tests. But you have to look at this and make sure you pass all the tests. Okay, and actually right now, over time, I have improved this infrastructure. This is still some old code I wrote, so I won't tell you where the bugs are, but okay. If you have any problem like that, you can just let me know. Make sense?
Yes.
Okay, so I've shown you the secret to working a little bit more efficiently. use the tests and they will help you to write better code and find your answers correct and all that. Okay, so now let's go and solve some problems. So which one are we doing first? Are we doing the finger one first? Let's write some code quickly for that. And then we look at square root. Okay, Kiran?
Yeah, Vijay, I think finger one would have been done by almost all of us. If there's anyone who wants to do the finger one.
No, okay. So can you spend a minute with me? I'll show you something very cool.
Yeah, yes.
So, okay, so let me show you something very cool. I think all your code should look something like this,
Yeah.
right? Is it true? Okay. So what is the idea that we realize at some point that because the way the fingers are arranged, if you go back and forth, you're going to basically, repeat in steps of 8, right? And you do this by basically counting on your fingers and checking this pattern, right? And this is why there is the mod 8 going on here, right? We're doing mod 8 for all this stuff. Okay, and then it becomes an exercise in understanding if loops, if statements, and else if, and all that stuff. Most of you are able to do this, which is a good thing. This exercise was designed to help you with writing if statements. But I want to share with you, when I wrote this code because I am trying to convince you and myself that you can actually use a computer. Like, what is the first thing you did? You took your hand and you started counting on your hand, 1, 2, 3, 4, 5, like this. The computer is a good tool to simulate actions that we do. And so we use the computer as a simulator that can help us a lot. So let me show you a different piece of code. This code will do the exact same thing that you have done. It's really one line, right? But of course, it looks like gibberish right now. So let me explain. First thing is, in order to solve this problem, I need to generate a list, or I choose to use a list, okay? So if you look at this code now, you can see that what I've done is I've taken this string. So let me just put it in one line so you can read it easier. I've taken this string. I like to do the string.split. So I made one string with all the keys in it, right? Thumb, index, middle, blah, blah, blah. If I call string.split, it will convert this to a list, right? And will create a list for me with these values as strings in the list. Does everybody see this?
Yes.
Yes. Okay. Now, there is a very interesting idea here that if I take a list, so now I got a list S. And what does S look like? S looks like basically this thing, but it has, like, let me just write a couple of them. It basically looks like this thing, but it looks like this, right? It has these values in them, but they're actually strings. So they have the quotes and all that stuff, right? It looks like this. So, oops. So let me ask a question. If I want to create, so once I have this list of strings in a list of strings, if I want to create copies of this list, what do I have to do? Anyone? So I want to create, so I have a list like this. Right now I have only 2. Let's say I use only 2 fingers for counting, right? But I want to make copies of this list. So if I just go thumb, index, thumb, index, thumb, index, thumb, index, I'm only using 2 fingers to count. I want to count to 1,000 and ask which finger shall I end up on, for example. So then basically if I have a list of length 1,000, but with the fingers in each location, is my problem already almost solved? Do you see what I mean, or no? Ask me a question. Does everyone see this or no?
Yes, we still.
Yeah, try to ask it as a question if it's not 100% clear. You see what I mean? So I changed the problem quickly so that I don't have to type more. Suppose I had only 2 fingers I was using for counting, and I want to know what happens when I reach the 100th number, right? I'm saying that the simulation of the counting is to have a list of size 100 here, right? With in each slot the corresponding finger to the counting value. Does that make sense? The list has an index, right? We start 0, 1 or whatever. The list has an index. Yes. So for example, if I want to, does everyone see this or no? help me. Ask some question or I can proceed.
Yeah,
So
BJ, in that case, we need to know the formula that we are going to put when there are when there are countings up to n
no, no,
or up to I.
wait. Let's go simple first. Answer me, make sure we understand this idea. Suppose I have only 2 fingers I'm going to use for counting. And I want to know what will I get when I get to the number 4, for example. Right? Then I create a list of length 4. And I say that I start with the thumb, then I go to the index, then I go to the thumb and the index. So the number 4 is on the index. Right?
Yes.
If I take the 4th location in this list, I get the finger that I am counting on. Does everyone
Yeah.
see this?
Yes.
So I have created a list that is doing exactly what I am doing on my hand, right? This list is exactly replicating my hand. If I want to know which is the number, I say which is the index. If I go to that index and I look there, I will get the answer.
Yeah.
Everyone see this yet or not yet?
Yes.
Okay. So now the question is, how do I create? So for example, I want to see, let's continue with this example. Suppose I want to know what finger will be on 100. I have to create a list with 100 elements.
Yes.
But they have to be copies of my basic repeating pattern, right? Thumb index, it has to go like this. So how do I create a list of length 100, which has thumb index repeated? So who's going to help me with that?
BJ, this would be into 50 kind of thing.
That's it. So into, you multiply by 50, that's it.
Yeah.
Right? You multiply by 50 and 50 is what? 50 is basically 100 divided by the length of the original list, right?
Yes.
So that's it. Whatever my S was, my original, whatever, if I started with something, so you understand what I'm saying. I can easily do this, right? So,
Yes.
so this you can do, but I'm just saying that right now we'll just put 50 here. So is everyone with me right now? I have the list that I want. It has all the counting done in it. Now you tell me any number. All I have to do is, this is a list. I just have to index this, right? So if you want to know the ith number, all I have to do is take the index. Almost. But Python starts counting index from 0 instead of 1. So basically I have to shift it by 1. Everyone sees this?
Plus 1.
Huh?
You did minus 1.
Sorry?
You did minus 1?
Shouldn't I? So for example, Python starts counting from 0 instead of starting from 1. So Python's index will be 1 less than the index that I'm interested in, right? If I want the 50th location, I must look in the 49th place. Does that make sense?
Yeah.
Yeah. So I have to look 1 behind because Python started the index earlier than it should have.
Yes.
Yeah. Okay, so that's the stub of the question, and that's it, right? So that's one way to do it. Another way to do it is, if I don't do it this way, I don't multiply by 50 or whatever, I take a list of fixed length. What is the length of the list that I'm going to create here? It's this one, right? This is the repeating list. Whatever, I won't put all the brackets and everything right now, but this is the list that gets repeated. What is the index range over here? It goes from 0 to 7, right?
Yes.
So another way to do it is, if I want to, instead of making a list of length 100, which wastes a lot of memory and I have to whatever, if I have a big number, all I have to do is I take the list, the number that you give me, which you want, and I divide it, right? So whatever number you give me, I divide it by 8. 8 is the length of the list. Notice that if I do this, whatever number, if it's divided by 8, it will always lie within this list, right? And then I'm done, basically. Okay, so there are clever ways to do this, but anyway, this is the solution that I put up. Okay, why I'm spending some time on the solution is, I'm saying to you, Python allows us to simulate the reality that we are studying, right? It allows us to create whatever I'm counting on my fingers. It allows me to recreate it. And once I recreate it, finding the answer will be very easy. As I have shown you right now, my answer is only one line. So now I have to ask quickly, does everybody understand this answer? Here I have actually multiplied. I've divided by 8 because my list is of length 8. And also you can spend a minute, see why this +1 -1 is there, but the structure at least should be clear. But let me ask it as a question. Does everyone see this solution?
Yep.
So which one's better?
So if let's say so as per this one, I by
Yeah.
8, right?
Yeah.
So let's say we give I as 99. So
Yes.
99 by 8 is 12 something, 12 point
No,
something.
let me just, sorry, Prakash, let me explain. I was being very clever here, but I didn't mean for you to study my solution. But let me explain what I'm doing here. The list that I need to create could have been just 10,000 elements wrong, or could have been,
Oh,
yeah, could have been
you're
any
creating
size,
the
right?
list
But
based on
that
the
would be
number.
wasteful. Suppose you only need to look at the 100th element. Why should I create such a big list?
Yeah.
So I did little extra work to say, if you tell me which IA you need, I will create the minimum length list that is needed to answer your question. So that's why I'm dividing here with I. Okay. If you want to make your life easier, you could just make sure, even you can remove all this int by 8 and all. You could just put I here. Just multiply by I. Right? It's going to be 8 times too long, but who cares? So I'm just showing you that's just an optimization here, right? What you should have in your mind is you take the basic list, you make copies of it so that you have simulated the counting, and now you find the right index. That's it. Then if you want the list to be of optimal size, you can do all this extra stuff. Huh? So now I have to ask which one is which one is better?
The code wise, first one is better, but understanding wise, second one is.
Okay, that is what Sachin. No, before I answer Sachin's comment, let me ask the
When,
others. What about Prakash? What do you think?
I mean, from the coding perspective,
Sorry, Prakash, you broke up.
we are trying to use the minimum resource. That's all.
No, no.
Code-wise, the first one is better, and we are trying to use the minimum resources. That's what the idea is, right?
Yes. No, I mean, so don't worry right now about optimization. We're still discussing elegance, understanding how can I create less bugs, etc. That is the correct criteria for us right now. It's not a performance discussion. But what I'm trying to say is, if the first one actually reflects a simulation-based way of looking at things, just make the Python do what I'm doing on my hand. When I go like this on my hand, Python is doing exactly the same thing, right? So it's hard for me to make bugs. This one is a little bit more, I have to simulate it and then see a pattern and blah, 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 right? So I'm saying that I don't think you see it today, but I want all of you to look at these problems and say, hey, I could look at the world in such a way that I could just find the answer by simulation. Make Python do what the counting is supposed to do. Then the answer will come automatically. I don't have to do anything more. Right? So in that sense, right? And then the second thing is, of course, you must be excited that how can you do this in one line?
Yeah.
Right? Suppose I say simulate this counting my fingers, index, blah, blah, blah. And you ask how many lines of code is that going to be? If I don't show you the solution, you will say it's going to be 5 lines, 10 lines. I don't even know. What would be your estimate for number of lines? If you didn't see this code and I asked you to make a simulation to generate a finger counting problem, what do you think would be your answer? Anyone?
Yeah, for me, what I would have done is
Excuse
I
me.
would have found out the pattern and then what is the pattern that involve, what is the pattern involved, and then try to
Yes.
code it.
Yes.
But looking at the way you have done it, it's
Yes, yes. I want to teach you the pleasure of this, right? That it's so elegant. You think it's going to be a big code, but actually it comes out in one line. It shows you the power of Python, right? Something that looked a little bit big actually became just literally one line, right? I could have actually written in one line just to make it more visible. I wrote it like this in 2 lines, right? So please develop. I wanted to develop this abilities too. Okay, and that's why I said when we discuss solutions, there's always something cool to look at. Okay, it's not just getting the answer right. There are some clever ways of doing the same problem which we can discuss. Okay, so now we should quickly go to the square root question. So square root. So how many of you did this? What happened? And Kiran had some specific question about round. Was that in the test, Kiran?
Yeah, Vijay, that round thing is in the test stats. Yes.
Okay, test stats. So let me finish the square root. You had something about square root, you said, no?
No, I just bypassed that tolerance and iteration.
Mm-hmm.
I did it like as I said, I only created it for perfect squares. So whenever the value that is being passed is a perfect square, then only my function would work and it would give a proper square root. So
Okay.
that was the thing. So I was just trying to quickly finish the
that's
finish
fine.
the lab.
That's fine.
My focus was on finishing the lab and getting the. So for that, I think I have tried changing the test that you have given.
But then you can make bugs.
Yeah.
Yes.
I was trying to manipulate the test there.
Yeah, I was like, why did Kiran put a wrong test in there and then you get the wrong answer? Yeah. So yeah. Okay. So Kiran.
So Vijay, my question is, can I manipulate the test and still get grades, or is it that these tests are binding on us and we have to?
That would be a bug in my grading system. Then you will write the test so everyone passes without writing any code, right? You can manipulate the test for your own convenience. You should write your own tests. But the final check should be, can I pass the test that is given to me? Yeah.
That final check is fine, but in general, I was asking whether I could have rewritten test, find square root, and pass different set of parameters and used a simpler function, created a simpler function in the backend and pass the test. So my direct question is, can I still manipulate the test and pass, or do I have to, or are these written tests binding?
No. All I'm saying is find square root has to return 2, 3, right? It has returned the answer and the number of steps, right? So suppose instead of doing this, you only return the value 2, right? And you modified this test to return only the value 2. For example, you wrote a test like this.
Yes.
Right? Now you will pass the test. But when I come to grade you, you will fail the test because I will say you're not giving me number of steps.
Yeah, okay. That was my question. So that means I cannot get grades unless I clear the test like the way you have it.
No, because otherwise what you're doing is you're changing the requirement. You're changing the question then.
Yes, PJ, yeah.
Yes, and I mean, I would be happy to allow you to change the question, but then that means that you could just say, let me just change the meaning of square root. Everything is 1, right? You just hard code the answer equals 1, and then what happens? So I cannot allow that, right? Yeah. So you have to pass. So that's why I said you can write as many tests as you want. You can even override the test. But as a last check, you want to restore it back to the test and pass it so that you get the grades.
Okay, got it.
Yeah.
Got it
So
now.
change anything. Okay. But now let's go and look at the square root thing quickly. Okay. And ask the question, how do we do the square root problem? So anyway, before I go into the solution, what about anyone else? Tried this? What happened? Tell me something. It's too easy, too hard. What happened? Someone? Sachin, Prakash, Praveen?
So to clear my test, actually, simply what I did, Vijay, I wrote a function and simple function actually to get the square root of the number, but never cleared these test cases actually. Yeah, test code.
Yes. Okay, so let me just say, I want to tell all of you, right, that when I put these questions, I didn't just put like some, by the way, you can expect this from me. I try not to put just meaningless questions, right? If you take the effort, you will learn something good. So let me see if I can convince you of this. Okay. So what I want you to learn is that just like the counting on the hand, we make Python simulate what we are interested in. So here we are making Python simulate a very general problem. And the general problem is, if you take this idea, if you take a while loop, and then in the while loop, you put a function, okay? And the function, the signature of the function doesn't matter. Really, the name of the function is probably what I wanted to concentrate on. The function is responsible for telling the while loop when to stop. Does that make sense? Help me.
Okay.
Yeah, Peter.
Yeah. Okay. So I write a while loop, and then inside the while loop, I write some code that helps me. So let me write outside the while loop first. I'm trying to solve some problem. Okay. I don't even know which problem it is, but I start with some guess. Maybe my guess is 0. Then I write a while loop, and I have to find a stopping condition, which stop the while loop when I find the answer. That's basically the idea. Okay. But we'll worry about what is the stopping condition afterwards. Inside the while loop, all I have to do is I have to make a better guess. Whatever the code is required to make the guess better, right? So we'll put something like this: guess equals improve guess. Does everybody see this?
Yes.
What do you think about this as a strategy to find the answer to any problem? Can I solve any problem with this? There's only 2 answers, yes or no. So how
Any
many?
problem, but I think you can solve many problems with this.
Okay, so that's a good start. Wait, does everyone feel we can solve many problems like this? Or it's too simple? Can only do square roots?
That seems simple, yeah.
Huh?
That seems too simple.
Okay, so this is a good discussion, right? But I'm going to tell you, actually we can solve many problems like this. I don't want to say we can solve any problem. We can actually, technically, we can solve any problem like this. The only question is some problems might take a long time to get to the answer this way. So all of the performance comes from how good my improved guess is. Okay. But anyway, so that's a general thing. So now let's explore. So are you curious now to see how do we solve this problem using this idea? Square root is an interesting problem to use to test out this idea, right? Okay, I said I can solve many problems this way. Can I solve square root like this? So let us try to solve the square root like this, okay? So let us go and ask a question. First is, when do I stop? If I set the guess is 0 and I'm trying to find a square root of some number, when should I stop?
When the square of the guess is equal to the number that has been passed to it.
Okay, so this is a good place to do this. So we can say like this, right? I should stop. This is my stopping condition actually. You take the guess, you square it, you subtract from the number. If this is exactly equal to 0, I can stop. Right? If I'm going to get an exact answer. Does that make sense? Now, if I do non-integer square roots, then I may not get to the exact answer. There's no exact answer. Square root of 2 is not a fixed, it's not a, it's not a real number. It's irrational number, right? I mean, it's a real number. It's not a fraction. It's an irrational number. So it has an infinite decimal expansion. But if I'm going to get closer and closer to that number, I'll have errors in the last 10th digit, 15th digit, 20th digit. I will have errors further and further out. Does everyone see this? So maybe I'm not interested in square root up to the 10,000th digit. I only want up to the 10th digit. Does everyone agree with this?
Yeah.
So what happens? So when guess is 0, x is some number, then I start with 0, and as the guess gets closer to the square root, it will become smaller and smaller, right? This x minus guess squared will become smaller and smaller. And then, so I will say that if it hits some tolerance number, then I have to stop. Does that make sense? So there's some discussion here about whether it's greater than or less than the tolerance number. Just you have to spend a minute to think about. Okay, you have to worry about signs, and sometimes you can do absolute value here. There are some clever ways to write this condition. Can I leave that as a homework thing for you to think about? What is a good stopping condition if I don't want the exact answer? Okay, just requires 1 second with a pencil and just think about it. Can everyone feel that they can figure this out or no?
So Vijay, it looks like it will be less than or equal to tolerance number. That's it.
It will be what?
It x minus square of guess
Yes.
be less than or equal to, at max equal to the tolerance number. If it
Yes.
is greater than the tolerance number, then there's no point keeping the tolerance number.
Yes. If it's greater than tolerance. So then you're approaching from above, right? And as soon as you get under the tolerance number, you will stop.
Yeah.
Yeah. So I'm just saying, I don't want to working with signs like this and so on. You know, is it greater, less than? You have to just do it quietly in your head. If I tell in words, it'll take a second. Okay. So if I ask a question, should it be greater than or less than, here you have to just concentrate and get it right. Okay. I just want to focus on the structure more. But anyway, for today, you can just write equal to 0, right? Because you're going to get an exact answer. If you do integer square root. This is what you were doing, right, Kiran?
Yes, Vijay. But I was completely ignoring the other functions which are helping, like improve guess, stop condition, all these things.
Yeah. But I'm going to finish the solution. Then I'm going to ask you which one is better. Okay. So
obviously the tolerance thing is better because it is more accurate, and then it can.
No. It's nothing to do with tolerance, is what I'm saying. If I set the tolerance to 0, then the check looks like this, right?
Yes.
Okay. Let's focus on this case. Make sense? Focus on this case. But what I'm saying is the way my brain is working to write the solution is different than the way your brain is working. Right. My brain says, first I need to find out in an iterative protocol, I need to find out when to stop, which is an easy problem to solve, right? It takes me 2 minutes of thought to figure out when. I'm just guessing some numbers. When shall I stop? When it's exactly equal to the answer, I can stop if I'm getting exact answers, right? This is very easy to write the stopping condition. So we write the stopping condition. Everyone with me? Anyone has a question at this point? Because I'm going to finish the problem in a second. Okay. So now the next thing, any question on stopping condition?
No.
Is it hard to write stopping condition?
No.
Should be easy, right? Is it nice to write it as a function? I think so, because then once I write the function, I don't have to think about stopping condition anymore. Mm-hmm. Does that make sense? Just know that for any problem, you need to know when to stop. And then once I find the answer, my code will just work as it is as soon as I write stop condition. Okay, so the next question is improve guess. So the question is, if I start at 0, what is my strategy to improve the guess? I want to find square root of 25, let us say. What strategy shall we use? What is the simplest strategy? Come on, this should be easy. What is the strategy I can use? I start at 0. What is square root of 25 is 5. So I want to get towards 5. How do I get towards 5?
Start from 0 and
adding some numbers, say step size.
Oh, yeah, what is the simplest number to add?
1.
Yes, that's it. So is improve guess easy to do? Yes, the answer is yes. You can just add 1 to it. Okay, but can we actually take bigger steps? The answer is probably yes. Right? I could take bigger steps and be cleverer about it. But right now I don't need to. So just put 1. Guess is equal to guess plus 1. That's it. Right? Improve guess is just basically take the current guess and add 1 to it.
Yeah.
Okay, so now my question, is it hard to write improve guess? Then the problem is done.
Yeah.
So look at my solution now. All I did is I said improve guess, and then I added 1 to my step count so that I can count how many steps I'm taking. Right?
Yeah.
And then when I finish the while loop, I just return the answer. The guesses now contains the answer because I keep on improving my guess until I stop. The guess has the correct answer I'm interested in. And I return the guess and the step count, and I'm done. So how does this feel now if you wrote this code?
Pretty smart way.
Huh?
Smart way of doing it.
But yes, thank you for saying that. No, but that is the point, right? That I'm trying to say that code feels hard and difficult and challenging and error prone if we use a kind of non-systematic way of going about the problem, right? When I use a systematic way like this, the approach guides me to get to the correct answer. I'm not using super intelligence here, right? I'm just saying, okay, there's a simple way to find the answer. The answer is basically guess and check.
Yeah.
Yeah.
Basically, you're asking the computer, you find it out rather than me giving you a.
An algorithm, or actually, it is an algorithm. It's called the guess and check algorithm.
Yeah.
But my point to all of you is the guess and check algorithm should be in our toolbox. It should be the hammer. Every time you want a solution, you can take the hammer, right? Then later you can find, okay, it's not a nail I'm trying to punch into the wall, it's a screw. Then I can find a screw. I can write a better algorithm. But guess and check should be in our toolkit. If somebody is saying, please quickly find an answer for me, you say, look, I can find an answer. It's not very efficient. It's not very whatever, but I can write it quickly and get you an answer.
Mm-hmm.
Make sense?
Yeah.
It's like Sachin's got his ETL toolbox. If I say, Sachin, put some file in database, he'll open the toolbox and he will do it, right? So same thing here. Okay, so is everyone on board with this? Okay, was it worthwhile for me to show you this thing? Did it help impact the way?
I mean,
yeah, so my point to all of you is, look, there's a lot of, whether it is data science or anything, there's a lot of simple things like this that we should enjoy them, right? How to take something that looks difficult, organize our thinking so that we can arrange everything nice way, and then the code will start to write itself. Okay, you need some discipline to sit and type it, but it'll become easy. Okay, so we're done with this. So I'm closing this. Any questions here? Kiran?
No, Vijay, I don't have a question.
Okay, so why, Kiran, you didn't go this way? You wrote something else.
Yeah, Vijay, I didn't want to do this, these many steps. I was just trying to,
Wait.
have
Are you
short
saying I have more steps than you?
Actually, you have more functions. So I was like, let me do the quick, simple one first and try to crack.
Okay, so I want all of you to write the quick, simple one as Kiran suggested and compare it with this. And I'm telling you, quick, simple one will be a big blob of code. And if you have any error in there, you have to read the whole thing to figure out what it is, right? Whereas for me, if I have a problem, I know that, for example, improve guess cannot have any issue with it. I just did guess equals guess plus 1. There cannot be any bug here, right? Only thing I can have as a bug is I forgot to put return or something. So I'm saying this code is actually much more maintainable, even in a small example. Why? Because there's little components that are each responsible for doing the right thing, right? So for example, if my while loop doesn't terminate, it goes in infinite loop, I know the problem is with the stopping condition, right? And so on, right? So actually, huh?
Guess is the answer, right?
Say that again.
Guess is the answer. Why you're returning the step count? You want to see how many?
Yeah, because what I was going to show, but I didn't do it because a little advanced is, there are clever ways to do this problem. So here's the idea, right? Once you write this code, let me tell you this. Once you write this code, to make this code better, what is the thing we need to change? Suppose I say this code is taking too long.
Okay.
So actually I can do a performance analysis very quickly. Suppose I want to find the square root of a number. This code will take square root of n number of steps because it goes from 0 to square root of n. Right? So if I have some big number, suppose I have 10 million, it will go to square root of 10 million number of steps. So it will be very large, right? So now I come back to you and say, Prakash, can you please improve this code for me? What do you need to change, Prakash?
Need to change the step count. Maybe we'll have to, if the number is big, then no point going in loop of 1.
So not the step count, you have to change the function improve guess. Make sense?
Yeah, improve guess
Yeah,
the step.
but now notice what I told you, something very beautiful. To make the function more performant and have less number of steps, I need to make my change only in one function, improve guess. I don't have to worry about this whole blob of code. So now if we took Kiran's code, what happens there? Somewhere inside the loop, there's a step change there, right? You have to go find that place and fix it. Here, I know exactly where I need to. So I write a new function, right? Improve guess and replace the old one with a new one. Make sense?
Yeah.
Okay. So
Can you write some code and show us how to improve it? Just for this. Let's say we are trying to find out for some 5-digit number, the square
Yes.
roots. How will you do
yes.
it?
So actually, I really I am restraining myself, Prakash.
Vijay, I want to quickly answer to Prakash's question.
Yeah.
So Prakash, for example, you want to find square root of 4. Okay, it is 2. Now you want to find square root of 9. It is 3. So you can clearly see that usually the square roots are either half or lesser than half. Okay, so if you want to reduce the the step size, then you can start from the number you can only come up to 50% of the number whose square root you want to find. So you can come or you can reach up to half of the number at max. Are you getting my point?
Yeah. But Kiran, I would say the way this code is written, you're right. It's a good way to think. The only thing is the way this code is written, you would already stop because you're coming from 0. You will not go to half the number. You will stop very quickly, right? You will stop. Say, for example, I'm trying to find square root of 25. I will test 0, 1, 2, 3, 4, 5 and stop. I will not go to 12.
Right. Okay.
So the only way to improve this code right now is to change the step size. Make sense?
Yeah.
Okay. So now I'm going to give Prakash. I'm not going to write this code because it will take me a couple of minutes more, and I want to show you some other things. Okay, but I'm going to show you an outline. So the outline is very.
You need to write it.
Yeah. So let me give you an outline. So let's do the 0 to 25 problem. So basically, there's a way. The idea is that the solution lies between 0 and 25, right?
Yeah.
Now Kiran already made a smart guess, and she said, smart logic, and she said, the answer is actually not between 0 and 25, it's between 0 and 12, right?
Yes.
So what I do is I basically say, I'm going to change. So this is the, let's call it the low guess and the high guess. Let me just write low and high, okay? I don't have to type guess every time. So does this make sense? I start with low guess and high. So what is the low guess? In the initial low is what? So the first thing is I start with 0 and I can go with just 12. Everyone is okay with that? The answer is bounded inside this interval, right?
Yeah.
So now I'm going to say, I'm going to ask the question, if I split this in half, 0 to half of 12 is 6. Is the answer in 0 to 6?
Yes.
Or is the answer in 6 to 12? Right? So how do I know this? Well, I make a guess which is 6 and check if the answer is bigger than this guess or smaller than this guess. Does that make sense?
Yeah.
Yeah. So for example, if I do 6 squared, I'll get 36. 36 is too big, yes? So then the answer must be in the left interval. Do you agree or not?
Yeah.
So I'm giving you the algorithm now. So my guess is equal to 6. And I do the check and I say, oh, now I know that I have narrowed my interval down and I only have to worry about this interval, 0 to 6, right? Now I do the next step. I say, okay, 0 to 6 I split in half. So I'll get 0 to 3 and then I'll get 3 to 6. Okay, and my new guess will be 3, yes? So now is 3 too big or too small?
Small.
Well, too small, right? So that means my new interval is what? It's 3 to 6,
3 to 6.
right? And now I can use 3 to 6 and say what is the in between 3 and 6. So it'll be a little bit careful how you split the interval and so on. But right now you could guess 5, for example. right? If you round up or round down, depends. Or you could guess 4, right? So yeah, if you, let's guess 4 just to make one more extra step. So if you guess 4, then 4 is too small. So the interval, what is the interval here? If I'm guessing 4, the interval is 3 to 4 or
4 to 6.
4 to 6. Right, actually we should, when we do this, I should be precise here. You shouldn't put 6 in both sides, okay? I should put 7 here so that I don't overcount this, right? So this has to be basically 4 to 6. Actually, in this case, I'll straight away get the answer because in between 4 and 6 is 5. I check the guess and I get the answer is 5. That's it. So how many steps were here now?
3.
3 steps instead of 5 steps. But it looks like 3 and 5 because the number is small. Right?
Yeah.
So basically what happens is, if you actually calculate this, it was square root of n. Now you will get basically something like log n, which is smaller. Right? Because I'm cutting, so later we can discuss why is it log n, but you understand it's much more fast. But it's very fast. So quick question now. So all you have to do is this logic has to be implemented in the improve guess problem. Right? Improve guess. The stopping condition does not have to change. All you have to do is write a new improve guess. How many of you will write this?
For any number, I mean, what is the steps? I mean, is there a definite
Say
number?
that again. Say that again one more time, Prakash.
So for any finding square root of any number.
Yes.
So do you have a number of steps that it should be done in 3 steps, 4 steps, or it may vary?
No,
Just
so,
from the performance of the best practice perspective.
No, okay. So that becomes a whole course in numerical methods. Okay. So yeah. So already I'm saying the one I showed you just now is very good, but actually there is a better method, very old method, by the way. At least in Western mathematics, we'll give credit for that method to Newton. Okay, Newton came up with a method to find the answer very quickly, even faster than this. Okay, so then there's a little technology there, but yes, it's not very hard. It's also 5 lines of code only. So I would answer you by saying,
Vijay,
yes.
Vijay
Yes,
Praveen
Prab.
here. So,
Yes.
Normally a quick method for calculating square roots, which I apply, I
Yes.
mean, just for mental calculations,
Yes.
I find the nearest square roots,
Yes.
one on the left and one on the right.
Yes.
And then, for example, if you are calculating for 5, I'll take 16 and 25, 36, sorry, 16 and 36.
One more time. Which is the number we are calculating for?
5.
5. You want to find the square root of 5?
Yes.
Yeah.
So I'll take the square of the numbers which
Yes.
are near to it, the perfect squares of
Yes.
4 and 6. It is like
Yes.
for 4 we know it is 16 and for 6, 36.
Yeah. Yeah.
Now 25 is in between 16 and 36.
Yes.
It's more towards 16 and less towards 25.
Correct.
An approximate answer would be 4.4. Sorry, 2.4.
Why is it 2.4?
So the number, the square root of 5 would lie between 2 and 3.
So you're saying you took 0.4 because it is closer to 25 is closer to 16 than 36.
Yes.
Yes. Yeah. So this is, correct. These kind of thumb rules will work. But of course, Praveen, the question is, if I tell you, that's why the tolerance idea comes in. If I tell you I want the square root of 5, but accurate to 15 decimal places, right, or whatever. Now we have to do more work, right? So for example, this bisection, because I'm constantly splitting the interval in half, I can go to any level of accuracy that I want. Right? So these are more flexible. In other words, the question is, do I want so it turns out there are all kinds of clever algorithms. If you tell me you only want it to 2 decimal places or 3 decimal places, I could do some other tricks, right? But here, there's a general purpose question. How can I find it to arbitrary? You tell me the tolerance, I'll keep on going till I get the answer for you. But I will search for it in a most efficient way, right? And I'm saying that this one gets the answer in something like log n, right? Steps. But yes, thank you for sharing that algorithm, Praveen. That's cool. Okay, so will you guys try to write this, and then if you come back, I'll actually show you the solution. Okay, I can show you the solution, and if you're really interested, since some of you said you like math and so on, I can show you the solution that Newton came up with. Extremely beautiful, and it's very fast. Okay, so there are different. So this is the whole. So how can I say this to you, to all of you? People teach computer science, mathematics, algorithms as different courses. For me, they're all kind of in the same place. We are trying to solve problems. Sometimes we use a more powerful idea and sometimes we use less powerful idea. But notice this structure that we use today says it doesn't matter which problem you're trying to solve. I can come up with an answer very quickly. All I need to do is go away and think, how can I take a next step? How can I improve my guess in a better way? And I showed you one way to improve the guess by splitting the interval in half. The easiest way was just take a fixed size step, right? You can even come up with some simple ideas to take bigger jumps, bigger steps if you have something. So you can play and come up with your own algorithms too. So I will pause here. Give me some quick feedback. Is this an interesting problem or what? Like, I don't want square roots.
Yeah.
Yeah. I want to stress to you though, even though I showed you a square root problem, what I want you to learn is this iterative checking mechanism.
Yeah. That's what intention was. Yes.
Yeah, that's very powerful. And then the second thing is, from a coding perspective, I'm saying writing these little functions to move the logic into smaller blocks so that it's not one big while loop with all the logic everywhere is an advanced programming technique, right? And most beginners don't want to do this, but of course my job is to show you and inspire you to do this more and more, right? I mean, it's in the beginning, it's like I have to name the function, I have to create parameters, I have to send things here and there, blah, blah, blah. But the power I'm also showing you is tomorrow when I want to improve this code, I can just say improve yes and just change one function and I can do better. Just plug it in, everything's going to run. My tests are going to run, everything's going to work like boom. So my work is very, 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 very clear where I have to make the improvement. If I write a big while loop, then I don't know which thing has to change, blah, blah, blah. And if I write the tests, when I make changes, I'm not worried of breaking anything. Okay. So I will pause here. So let's do what are the, okay, so now stats.py. So now Kiran, your question comes. Kiran, what was your question about round?
Yeah, Vijay, the initial test that you had mentioned did not have the round function. The round
Correct.
function was added later.
Correct.
So my problem was that I was not able to match all the digits, especially the last 2-3 digits, when I found the standard deviation.
Yep.
Okay. So I had to manipulate this answer. Yeah.
Let me make a statement. In general, when working with floating points, we should always use rounds to compare values. Okay, in general, because we can produce rounding errors in mathematics, in programming, always. But actually, the rounds are not that, the rounding errors are not that pronounced. So I usually don't put round because I want the rounding errors to tell me some story. And actually, I found that the story is rather strange. The rounding errors seem to be Python version dependent. So I haven't figured out exactly why this rounding error is there. Like if you run this test without the round in a Jupyter notebook right now with Python 3.5 or whatever, the latest version of Python, you don't need the round. It'll actually work without it. So anyways, there's some deep thing about, I don't know whether they changed the floating point operation in the Python version or something, okay? So anyway, in this version of Python, we do need this round. And I don't even know what changed, because maybe some upgrade came or something, I don't know, because this was not needing the round before, but it does now. So I don't have much to say about the round, except to say that if you're writing tests of floating point operations, you should always do comparisons up to some degree of precision. You should always use a tolerance. It is a good practice. Make sense?
Yes, Vijay.
Yeah. So yeah, but I'm just explaining why I don't use it always, because I want to know when the rounding is causing trouble. I really want to know. I don't want to hide it. If I put the round there and then I'll never know when there's a discrepancy. I'd rather have a problem rather than hide it. Okay, but you should decide what you want to do and do it. Okay, so let's go back and ask, okay, how did you write the solution? So let's start with, I don't know, yeah, standard deviation or mean. Let's start with mean. How did you do the solution? Sachin or Kiran or anyone, Prakash, Praveen, tell me how do you calculate mean? For loop.
So Vijay, for the values had to be present in list. So house prices was already in a list.
Yeah.
And the mean was for I in the list value.
Don't give me the full solution. Give me the strategy. What is
Okay.
the strategy? For loop.
Yeah, so it was a for loop.
Okay. What about Sachin? What is your strategy? Sachin's not saying anything. What was your strategy to calculate mean?
So the only I can see, like I can think about the for loop, but yes,
Yeah.
maybe in Python something actually we can do it quicker way.
No, I'm saying I don't want to make anyone feel embarrassed to say you're using a for loop, okay? But my job is to show you better ways than for loop, that's all, okay? So for is a good strategy, no harm, okay. What about Praveen and Prakash? If you have to calculate the mean of a list of numbers, what is your strategy?
Sum it up and divide by the number of in the list.
Correct. So how are you going to sum it? That's what Sachin said. He would put a value, call the answer equals 0. He'll go through a for loop and keep adding the value to each time to answer. This is Sachin's strategy, right? Or whatever. Kiran, Sachin, everyone. Even now, question is, Prakash, are you joining on this strategy? Same strategy to calculate the sum?
So Vijay, I'm sorry to interrupt here. I have not used a for loop there. I have just used sum and length.
Okay.
So sum upon length directly gives the answer.
Okay, so that's the correct strategy, right? So the mean should be basically in Python. If we are going to do this, you would say return, and then you do sum of L, right? Sum is already a Python function. It knows how to sum the list.
Yeah.
And then to get the mean, I have to divide by the number of elements. That's also a function. It's called len.
Yeah.
Right? And then we're done. So Sachin, is this better than the for loop?
Yes.
Okay. So then what about the standard deviation?
I'll check my solution.
Okay. In the meantime, what is the strategy for standard? Who remembers Yeah.
So here also, Vijay, I've used sum, length, then denominator is actually length minus 1, and average is sum upon denominator. Denominator was length minus 1.
Okay. So can you give me a Kiran, why don't you explain the solution to the others?
Okay.
I'm going to just find something. I'm going to find your solution.
Okay.
Yeah. So go on. Explain your solution. Just tell them what you do.
Okay, all right. So I basically, house prices is a list. Okay, so I first found the numerator. Numerator is nothing but sum of the whole list, sum of numbers in the list. And then I have found the denominator, which is length minus 1.
Kiran, does this look like your solution?
Which one? Vijay, have you shared something?
It's on the screen, no, or not?
No, the
Let me,
screen says editor settings.
yeah. Do you recognize the hand of Kiran?
Yes, Vijay, this is my solution.
Correct. Okay. So now you can talk to it.
Yep.
Yeah.
So basically, I have calculated numerator and denominator here first, so
Yes.
that I can find the average
Yes.
or the mean. And once I have found the mean, I have used a for loop to calculate the deviation of each of the elements of list from or from the average. Is that clear?
Yes. Does everybody see this?
Yeah.
Okay. So what? So now first, Kiran, I have to just tell you one thing quickly. This float is not needed, right? Why did you put a float here?
Because Vijay, when I was doing numerator upon denominator, that
Yeah.
is, then I was not sure whether I will get the decimals as well here.
Why would you not be sure? If you divide 5 by 2, you should get 2.5, yeah?
Yeah, Vijay, in some cases, it just, when I do 5 divided by 2,
Yeah.
it just returns 2, and that's it.
It's not possible. Okay, I will tell something very important, but unless you do the following, the only way to make this problem is to go to an old version of Python. Python 2 point something will have this feature.
Okay, so
But if you use Python 3, it's not a question. If you divide, you'll always get a corresponding floating point.
okay, maybe in my previous sessions I would have used Python 2 point something, which would have.
I never put anywhere, but okay. Let's get it out of the way though. Okay, it's very important. It's a very important bug, by the way. It's a big bug between Python 2 and Python 3, right? So you cannot, you can, yeah. So if you want integer division, you must put double slash in Python 3. So you don't need that. So you just get rid of this, makes your code cleaner, nicer, blah, blah, blah. Okay. Okay. So now that you've done this, okay. So now the rest of it.
This is possible because sometimes I use the online notebooks to run. Instead of Jupyter Notebook, I use online notebooks. So maybe while I was doing the first session.
Wait. What Jupyter Online? The ones I gave you?
Yeah, no, Vijay. So sometimes I use the regularly, like generally available online Python IDE.
Like you want to show?
If you type online Python online, you will get an IDE.
Okay, just do the following. Send me a link. I'll look into it. Okay. But the only point I want to say to you is, if you go end up in Python 2 point something, you're going to have this problem. But right now, today, I don't recommend to anyone to write code on a Python 2 point something interpreter.
Right. Okay.
Because these kind of things will cause problems and bad patterns, right? So even if you use an online thing, you must make sure there is a Python 3 dot start, right? Typically 3.4, 3.5, even where right now the online Jupyter notebooks I gave you is 3.6. So why don't you just use those notebooks? Just make another session for yourself. Notice here that when you go to the online notebooks, you get a choice of the kernel.
Yes.
Yeah. So just choose the right kernel. Okay.
Right. Okay.
Okay. Continue. So finish this. So at least the standard deviation finish.
Yes. So from that average number, I have tried to calculate standard deviation of each of the values of house prices.
Yes. Okay.
So for that, I had to use for loop.
Okay. So let me just show you. This is your solution, Kiran. So I'm going to show you. This is your solution. I'm going to show you my solution. Okay. You see already it's a little less crowded.
Yes.
Okay. So let me just show you what is done. So the mean, we have already created a function for mean. So notice here how you basically did not reuse your own function.
Yes.
We should not do this, right? If you already have a mean function, we should use it. So my code therefore becomes simpler because I just use what I have already done hard work for.
Yep.
Second thing, I use this very simple idea for each element. So let me just explain this idea. For the, I have a list of numbers. For each element, I need to subtract the mean and square it. So I wrote a function. It's called a lambda function, right? So lambda function is basically, instead of writing a function with a name, so I could have actually used a function with a name. So let me just do that just to make it easier. So I could have just def this and call it f for now, okay? And then I'll write the signature in a second. I'll just paste this here. So you see this lambda function takes one parameter. So this function needs to take one parameter. So I pass in an x here. For any x, I have to calculate basically x minus mean squared and return it. Right? This is what I have to do to compute the standard deviation. Does everyone agree this?
Yes.
And then I have to submit basically. So all I do is I do a map. Map allows me to take any function and map it on every element of the list. So I do a map. That is my for loop, Kiran.
Okay.
So now you tell me, is this line of code here, one line of code, is this better than this whole for loop or not?
Yes, yes. VJ
Yes.
Definitely it is
Yes.
better.
So I can show you other ways of doing it, but I think this is the most clean and compact general way of doing this, right? So list.map function over the list, right? That's it. And this last list is here because map actually is a very clever Python function. It basically, Python says, I know how to do the calculation, but I won't do calculation until you force it. It's called a lazy evaluation. So it will create a thing that contains the answers, but it will not evaluate the answers. So to force Python to evaluate the map, you have to basically ask it to make a list for you. Then it will evaluate the map. So that's requiring just an extra line of extra function call there. But then my code is done. So if you don't want to write this, then you could just use the lambda allows me not to, I don't need this function anywhere else. It's not a reusable function. I need it only in one place. So I can write the whole function in place. So I know Kiran said we didn't discuss lambdas before when you missed a class or something. I don't remember.
Yes,
But anyway.
I don't understand lambda, but I was able to understand the function that you just wrote.
Yeah, that's
F-
it. So the idea with lambda is instead of giving the name of the function, for any function, you call it lambda.
Okay.
Then you write the parameter and inside you write the body of the function. The important thing is you use lambdas only for functions that are very short and one line, a half line or whatever. If it's 10 lines, 4 lines, 8 lines, then you write a separate function. That's it. And Prakash and others who use C# and so on, you know these as delegates or anonymous functions, right? So this is there in other languages also. And that's it, Kiran. Then I just do square root and I'm done. So now we have to quickly ask which solution we like right now. Sorry, unfair competition.
People will vote for me, VJ.
Okay, nothing wrong, because there is a reason why we write code like this, right? Like you have written, Kiran. And the reason is not necessarily a good reason. The reason is this is the habit we have. This is what they teach us in Intro to Programming. But my goal with this whole example is to teach you that should we not consider better ways of doing it? Because it's so much less chance of making a bug here, isn't it? Here you could have forgot to initialize a variable, you could have forgot to increment something. Various things are possible to go wrong here, right?
Yeah.
So at least let me ask that question then. Do you have even if you're not writing this code, do you feel like you want to write code like this?
Yes.
Okay, that's a step forward. What about the other? Sachin, you feel like you want to write code like this or not?
Yeah, the second one, my vote goes to you.
But then we need to sit and explain what you have written. Huh?
Yeah.
In project, then you have to do a lot of documentation to explain this.
Well, so it's an interesting question actually. I do not like code that needs further explanation, right? And my belief is that in this new world, all of us will understand maps and lambdas, and we're not writing documentation. A very important thing when I show you this, it's a dangerous weapon, right? We don't want to write code that is one line and nobody can understand it. Yeah. That I don't like, right? But the idea here is, yes, you don't understand it today, but if you're writing this kind of code, this pattern will be a pattern that doesn't require extra documentation. There is as much information here. Like when I'm reading this code, I'm saying, oh, what is this person trying to do? He's taking a list, he's mapping a function onto the thing, and he's evaluating it, calling this list function. I can read it just like this. In fact, I'm going to ask you the question, if you see this code, can you figure out what this code is doing? Which code? So let's ask this question seriously, because Prakash brought up an important point. Which code is easier to understand what it's doing? So here, you know that I'm calculating the mean. From Kiran, can you tell that she's calculating the mean here?
No.
No. Okay. Then she's got some for loop. Do you know what it's trying to do? It's hard, right? You have to go inside the for loop. You have to know what total is doing, blah, blah, blah. You look at this.
She needs to write comments on top of it. What she's doing.
Okay. So I'm saying that this code is actually not just it's compact. It is more declarative of what it's trying to accomplish. Right? It is, I'm also saying it's actually better self-documenting code. The only reason why it's not familiar to you is because map and lambdas are not in your bread and butter, right? If you're,
Yes.
Yeah, if you're breathing and eating maps and lambdas, you'll be like, oh, of course I know what it is. Okay, so there is a case. This is not that the code 2 requires more documentation. Code 2 requires less documentation. So I don't expect it to happen. I don't expect it to happen overnight. But I do expect that you get an appreciation for it. You want to do it. And in certain places, after you write this kind of code, you can ask the question, at least, can I do it in a better way? And if you come back to me, of course, I can think about it and show you.
Hey, Vijay, sorry to interrupt.
Yeah. Yes, Mani.
So what's the plan in terms of this course? Where are we?
So in terms of this course, we are in our officially the last session.
Yeah.
Right? And actually, today we decided I had this whole visualization of Python graphics planned.
Right.
We decided to put that on pause and just consolidate what we already discussed.
Okay.
So we actually went back to lesson 1 and we're doing lab lesson 1, going through all the solutions. Right?
Okay.
I thought I could do all the 3 labs, but we had plenty of discussion. And I'm finding, for at least my opinion, for us, it's better not to rush anything and just cover everything and build up a base that is solid.
Right.
Because if we rush forward, then we are missing a lot of things from the discussion today. But actually, I will just turn around. Kiran, does what I said make sense?
Yes, Vijay, it makes a lot of sense. And I had discussions with each of us separately. And we all were of the view that we need some practical data management.
Yes. Okay, so that was the other thing I discussed with Kiran, Manish, was that we consider right now, if I look at this group of people, what is required is probably just some time to write code,
right?
Solve problems, right? Not new ideas like we're doing right now. It's just an example, find the square root of a number or calculate standard deviation, something. But write the solution, come to class, or because, okay, so let me, and I want all of you to interrupt me, or after I finish, make a comment if I'm not saying anything reflecting where we are. Most of the work is happening in the class.
Right.
And people are trying, but bulk of work is happening in the class. So I think we have to, if we go forward, we should be thinking of using the class to build the experience. Making a plan that everyone's going to go home and spend 8 hours and 10 hours is not going to happen, I think. So when I talked to Kiran, I said, look, okay, we meet on Sunday. I will give one problem in the beginning of the class and we will write code. Right? And in the process of writing the code and discussing the solutions, we will learn something.
Right.
That will be the only best way to consolidate what we have already discussed.
Right. I
fear that if we don't do this, then whatever has been learned will just evaporate.
Yeah.
Right. So that was my comment. So we are not yet at a plan stage, but this is what I had discussed with Kiran. So Kiran, you were saying you discussed with others and all of you feel the same way? I think Kiran is on mute. Okay, I can ask.
Vijay, sorry, please. Please ask. You were asking something.
No, I was asking that you said you discussed with others and you feel the same way what I just summarized?
Yes, Vijay, yeah. I had discussions with Prakash, Sachin, Praveen. Only Pallavi I couldn't speak to because her phone was off.
Okay.
So I think probably it will make sense that Kiran, you discuss again once and propose what you want to do, and then Vijay will see our schedule as well and see what will work best for this group. right? Yeah, definitely they need Sachin, Prakash, Kiran, Praveen, Pallavi, they need some more practice. So we'll try to put together something which
Correct.
will help them to take it forward. Again, I was talking to Vijay and saying that most of the people, like 99% of the people, are so familiar with clicking some buttons and they never get to write some real code. And there are very, very few people who can write this kind of code. And if you can write this kind of code, you are like very, very valuable if you can write some good code.
Yes.
It's very hard to find people who can write real code.
Yes. Yeah.
All
So,
right, so I'll take off. Okay, I'll be around. Okay, if you need me,
yes.
just give me a call. Okay.
Yes, Manish. I'll ping you after as soon as I finish.
Okay.
Yeah. So yeah. So it's time for us to maybe pause here because we covered a lot of stuff today. But what I discussed with Kiran, I repeat to you, right? Maybe we can design this course. I have to create a course called Practical Data Management. And in that practical data management, we basically have to come up with good problems and just write code and discuss it like we have done today, right? And hopefully, I mean, I still hope that you guys will do some practice offline. But if you're not, at least in the class, I can try to give some flavor of things. For those who wrote these solutions, do you see the benefit of trying to write it in your own way? So when I show you something better, you are able to connect to it, no?
Yep.
Yeah. So okay, so let's follow up on that idea, right? Create a course. But of course, Sachin, also I asked you for some ETL type problems, etc. We can, if you propose me problems, I can include it.
Sorry, Vijay, for this time. Yeah, but yeah, before the next class, maybe in a day like Monday or Tuesday, I'll email actually to all of you.
Yeah, no rush. Just when you're ready, right? When you're ready. Yeah. But okay. Otherwise, Prakash, how do you feel? Have you learned? What do you feel?
Yeah, frankly, I could not practice due to some
Yes.
other reasons, but it's really interesting. But one more question, since you're
Yes.
saying this is the last session, so even after we can go ahead and practice and submit the
Of
lab.
course. I have not closed anything. If you have any trouble, sometimes there are some dates there, Prakash, because I put some cutoff dates there. But if you want to submit anything, you have any problem, just send me an email.
Yeah, sure.
Right, and both in terms of submitting and if you have questions, don't hesitate to ask me.
Okay, sure.
Right.
So Vijay, what will the next course exactly consist of? Will it be these problems being practically solved in sessions like
No,
this?
I mean, I show today we only discussed the Python problems. But what I want to do in practical data management is focus on the pandas type of problems, right?
Okay, yeah.
Take a data set, we load it, we filter something, blah, 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 right?
Yeah.
And I have some ideas for some interesting projects. Like, for example, there's a data set that has all of the IPL matches from 2006 until 2016 or something, 10 years worth of data. So then we can take this data set and we can try to find out, for example, I'll give a problem. Is a team playing at home more likely to win a match or not? Right? If Mumbai is playing in Mumbai, are they more likely to win than playing away? So now you have to go to the data, you have to filter it, you have to group it, you have to calculate the likelihood of winning, right? You have to calculate something. And even though in words it's easy to say, practically you have to manage the data. You load it, filter it, blah, blah, blah. You learn all these techniques. So we can do a lot of interesting, like if you look at lab 3 already with the Titanic data set, I've given some examples there where you go and try to predict who is likely to survive or die or something. So they are like baby data science projects, but they are focused on massaging the data, loading the data, filtering it out, deleting the NAs, whatever you have to do to manipulate the data, right? So, and that's why I asked Sachin for some ETL-like problem. If you want to practice how to write data to a database or something, okay. As you've already seen from the classes, it's not very hard to read and write from the database, right? I mean, we write one function to take care of it and we're done. But I can show you those kind of practical real-world situations. What can I do if I need to do this or I need to do this? How will I write code? But I am not focusing that on Python, unless you tell me otherwise, Kiran, or you give me some balance. You say do for 2 sessions, do more Python, then go to data. But you tell me what is needed. Actually, I will ask right now, do you guys have any sense of which way you would like to lean? or you want to discuss it amongst yourself and come back?
So Python session will give will be more oriented toward the data science, or I mean more on the coding side, and this the Panda series that you're saying is maybe on the data management side.
Yeah. I'm saying that I can give you some interesting Python like this. What we did today, no? Calculate square root or something. Or I can give more interesting Python problems, but they will focus a lot on Python code, right? Probably we can try a few sessions of data management itself and see if that is adequate. I can't tell at this minute. Also, it's your interest, right? I definitely think that we can do a lot of interesting things with the data management piece already. As I was saying, no, if we go to, let me just open up this lab 3, for example. So if you go to lab 3, in lab 3, what did we do? So for example, we did, let's see. So here, for example, we are calculating all this stuff using pandas, right? So let me just make it a little bigger. Yeah, so we had to calculate, for example, we had to connect to this database and find the max min date of birth of the participants in a course or something, right? So this will allow you to test your skills how to do this, right? And if you write a few examples like this, you will become an expert at retrieving data from the database and doing a calculation on it, right? Then there's some tougher question like this: calculate the average score by course. So this will actually require you to merge different data sets from the database and do in-memory joins and all this kind of stuff. So you get to practice, right? Literally to work on these kind of problems. Or this Titanic problem is another example. Say, look at this Titanic data. It's some messy data like this, right? So if I show you this file and say, find out, you know, is a male person more likely to die on Titanic, or female is more likely to die on Titanic? It's impossible, right? What the hell am I going to do with this? But then we can write some fairly simple code actually and be able to predict, right? If you look at my code, you can see see my code looks like this. There's not even any code there. But I don't have time to go over this particular example today, right? But does it address your question, Prakash?
Yeah, it does.
Yeah, so the idea is to do some practical examples like this, right? Which is some real world like kind of data, and then actually solve the problems, right? And you can also propose, if you find some data set and you want to do some analysis, if you let me know in advance, I can incorporate that too. But if you start writing code for that kind of stuff, then I think you'll become very, very quickly, you'll become, you know, proficient. Right now, if you see code that looks like this, you'll be like, how does it work, right?
Yeah.
I don't know if it's a disease of my code or this is how the world is. My code is always very short and tight like this. I try not to write too many lines if I can help it.
PJ, you write the whole program in just one line. So we need much more practice to come to that level.
Yes. This is my point, right? Hopefully, not just practice, but we can have some fun with it too, right? Every time we see something nice, we enjoy it. So why don't you guys discuss, and then Kiran send me an email or Sachin, or we can get on a phone and talk and figure out what we can do. Okay, but definitely I would stress again to all of you, the benefits, as Manish said, if you learn to do these things well, there's tremendous benefits, right? To your careers, to your productivity, even just to your thinking, right? Because we become more organized in our thinking. So this will be a tremendous benefit to all of you. So make sure that you continue to pursue it, right? And if you have questions or you're not sure, come back and ask me, right? But I think it will definitely help you in many ways that you cannot see right now.
Mm-hmm.
Okay, with that said, it was so much fun working with all of you. Keep up the good work and send me emails, and we'll connect again soon.
Yeah. So Vijay, are we connecting next Sunday, or is it that after deciding we'll
I
connect?
don't know. You let me know. No, you let me know if you guys are ready. Then we can go.
Okay.
Or if you need a week of break or something, I just figure it out and let me know. So the
We
most
can-
important thing and the challenge to all of you is I am trying to be very flexible. It's a good thing and a bad thing maybe, right? But if I am being flexible, it means you guys must push, right? You must say, I want to do like this, whatever. Give me some inputs, okay? So yeah, I am not trying to be very rigid. So figure it out. Give yourself a good shot. Have some nice experiences. Sachin, what's the score?
165 for 2. Australia.
Okay. Thank you for the update. Okay, I'll let you guys go. I want. Thank you so much. Send me email and we'll talk soon.
Yeah, sure.
Thank you so much, Vijay. Thank you.
Thank you.
Vijay, can we have one concluding session on next Sunday also, which would be basically on these questions? So maybe we'll pick lesson 2.
Of course,
Or
yeah, sure. Let's plan it tentatively. Kiran, I will confirm. Okay. So
okay. Yeah.
yeah.
All
Okay.
right. Thank you so much.
Talk soon.
Thank you so much. Bye bye,
Okay.
everyone.
Bye.
Bye.
Thanks.
Have a good.
Thanks.